Thanks for joining us. So, quick story. In 1982, Walter Doherty and Avin Thadani published a research paper in the IBM Systems Journal. And it set the standard for computer response times to be 400 milliseconds. The previous standard was 2,000 milliseconds before that, or 2 seconds. And their research found that when a command was executed and returned a response within 400 milliseconds or less, it was deemed to be addicting to the user. That is now known as the Doherty threshold. And that was 82, right? So what does this have to do with e-commerce? Over the past 3.5 decades, the technology has changed significantly, but human nature has remained constant. And as ISPs and servers have gotten faster, code and design more complex. And users really been caught in this tug of war. So keeping with the zero lag tradition of focusing on performance, conversion rates, and optimization, we'd like to share today some tools and process to help increase the performance of the sites that you build. So the link between site performance and conversion rate is well established, right? Let's get started with some basic statistics. Conversion rates can drop 7 to 10% for every 1 extra second of page load time. So, put it in perspective. There was a study for Amazon and Walmart that showed they increased revenue 1% for every 100 milliseconds of reduced page load time. If you're doing $30 million a year, 1 second of slow page load will cost you $2 to $3 million. So now that we've set the stakes and defined the stakes in dollars, right, let's talk about websites. We found that our average client site, Magento site, loads in roughly 5 seconds. And the global average for e-commerce, as I understand, is about 7 seconds. Are we all on the same page on this? Okay. So studies show your homepage should be loading in 2 seconds or less, right? But it's a moving target. In 1999, users were willing to wait 8 seconds. In 2006, 4 seconds. In 2010, we're down to 3. And in 2015, it was 2 seconds, right? So based on the velocity of broadband improvements and upgrades, if I had a crystal ball, and I looked in it right now, it would tell me that not long from now, users would be expecting your page to load in 1 second or less. So the question is, how do we get there? This is the challenge as we see it, right? ISPs getting faster, servers becoming more robust, and then design and code getting heavier and more complex. And users are stuck in the middle. Over the past 2 years, we've incrementally tested the IR Top 500, and we have not seen almost any improvement over that period of time. So it's really been stagnating, even though broadband speeds are getting faster, servers are getting faster. You're going from hex core to octa-core to 12-core. The rate of improvement is exponential, but still no difference in the last 2 years. Based on our research, as we understand it, the home page should begin rendering within 700 milliseconds or less. It doesn't mean it needs to complete, but the user needs to see a visual response from that page in 700 milliseconds or less. And that's not far off of 400 milliseconds, right, for the Doherty threshold. So something that 2 guys figured out in 1982 is now extremely relevant in 2016. So the reality is that there's really only so much we can do as a hosting company on the infrastructure and server side. The rest is up to you. So the solution that we found, the most effective way to improve site performance is not tacking on extra caching front-end pieces to sort of band-aid things. It's about getting into the code, figuring out where it's not efficient and fixing it. And by no means saying that anyone is writing bad code. Everyone's writing great code, but we can do better. And it's the extensions, interacting with one another, causing loops and things like that. So profiling code is so important. How many of you are familiar with code profiling in general? Okay, so a few people. And do any of you guys use it in your daily or your regular development process as part of the process? Okay, but only a few, right? So, well then this will be a review for you. To review, a code profiler dynamically analyzes and measures performance in several different ways. And the profiling information can be used to test efficiency and document improvement or degradation resulting from changes to that code. Very straightforward. So you can measure memory and CPU utilization. It's all listed here, but just to review. Computational complexity, instruction set usage and scheduling, as well as frequency and duration of function calls. So the two most useful pieces, I don't know if you guys find the same, but really the two most useful pieces here, I think, are memory and CPU utilization against frequency and duration of function calls. With those two things, you can look at an application and know, hey, I'm using way too much resource, and these function calls are all taking too long. And you can start to correlate and really drill down and find the issues. So today we're going to talk about 3 different tools. They're all open source tools. We're talking about ChromeDev Tools, which I'm sure most of you are familiar with and probably many of you use all the time. Xdebug, which is a PHP profiler, helps identify broken or inefficient code in PHP, and it's packaged with PHP, so it's a native PHP extension. WebGrind displays cache grind files. So when you run a profile in Xdebug, you can view it with WebGrind. And there are a number of different tools to view cache grind files. We chose WebGrind because it is a web interface as opposed to running on your local machine. That means that we can deploy it configured and ready to rock on all of our dev instances for you. So you don't have to worry about installing, configuring, or any of that. It's ready to rock. So let's dive into each of these tools. ChromeDev Tools. So ChromeDev Tools provides deep access to the internals of the browser and how it interacts with the web application. It also allows you to track down layout issues, such as JavaScript breakpoints, get insight in code optimization, and really get an idea for how some of the Java features are functioning. Real world example. One of the partners we were working with was having an issue, and everyone's looking, nothing looks broken. Everyone's kind of banging their head against the wall. What do we do? One of our engineers popped open ChromeDev Tools, ran a profile on the site, and what he found was that a third-party module, it's not even custom code. I mean, it's not like someone made a mistake. It's just a third-party module. That module's JavaScript was modifying Magento's AJAX handling, and it was breaking the one-page checkout. No one could figure it out, but ChromeDev Tools, it was obvious in an instant. So this is, we're going to take a look at some slides from ChromeDev Tools. We're looking at 1.5 seconds of a 60-second session. So it's showing the very beginning of the DOM processing. So there's a couple different sections we've highlighted here. Red is frames per second. Orange is CPU utilization. Yellow, network utilization. Green is screenshots. And then the blue is Java memory utilization. One of the things I really love about this is that you can look at all of these things against one another in one stack. So you can see the screenshot, you can see what the network was doing, you can see how the CPU is handling, and understand how many frames per second you're rendering. It's really good visualization. So this is the same slice of that session, and we're basically seeing which function or which activity took how much time. And what we can see here is that scripting and rendering take the most time by far, okay? Just to go through them really quickly, loading is transferring assets from the server to the browser. Scripting is the browser-side script execution for things like Java, JavaScript, and ActiveX. Rendering is the DOM recalculation from the results of the scripting to do things like resize images and make layout changes. Painting is just updating the window with the information from scripting and rendering. Other, from what the best I could find out, other is random tasks like garbage collection, but there's not much more detail about what other means. And then idle is just the browser waiting for the user to interact. But scripting and rendering. So ChromeDevTools can help you identify the inherited properties of a DOM node. And why that's important is it can help you determine if there are excessive CSS overwrites of CSS selectors, right? And that increases the rendering time. We've highlighted the discount codes DOM element, or node, as it's called. And then you can see here, these are all of the different CSS styles affecting that DOM node. So that's enough on ChromeDevTools. We'll move on to Xdebug. So once again, it's a PHP extension. It's native to PHP, so you don't have to install it. It's already there. And it runs profiles and traces for PHP code. I think one of the best things about profiling is that it really gives you critical performance information, like CPU time, not necessarily how much CPU, but CPU time, memory utilization, and then external resource utilization per call. It's granular. So we've got this is from WebGrind. So we've run a profile in Xdebug, and then this is the visual output when you load that profile into WebGrind. So we can see here that this call, to run this call is taking 26 seconds. And we did this, okay, so this is a really extreme example. This was run on a Magento EE 1.14 deployment with 308 top-level categories and 2 million SKU. So this is exaggerated grossly, so it's not always going to be this obvious, but we had a lab set up like this, so we figured we'd run the test on that. So 2 things to remember when you're running profiles. Number 1, you have to have Magento Developer and Profiler enabled in order for most of the class and function names to appear in the Xdebug profiles. And then also, the profile will take 10 to 15 minutes to run, which means you're going to time out on the web server, but the PHP process will continue running as long as you're using PHP FPM or SuPHP. So let's drill down into some of this information. And by drilling down, you can see all of the functions that call and are called by get disabled IDs. We see that the code here is looping through 16,500 categories and subcategories in order for it to figure out what belongs on the homepage navbar. And that's what's causing this 26-second delay in loading the homepage because it's trying to figure out what to put on the navbar. This site has, in this example, there are 3,000 categories, and the highlighted functions loop through all of them before sending a response to the browser. So looping through all of those categories is essentially holding up the render of the page, which is just precious time ticking away. And just to sort of close the loop here, we reduce the number of top-level categories. It solves the problem. But this is the tool that we use to get that granular level and try to figure out what it is that we really need to affect. What do we need to change? What do we need to work with the developer to change? WebGrind. WebGrind is an open source cache grind file display module. Like I said, we chose it because it is a web interface, so you don't have to install anything on your local machine. You know that it's installed, configured, and ready to go on your dev instance if you're running at zero lag. And to conclude, I was just missing one slide, so that's good. Key takeaways here, right? We all know that conversion rate is driven directly. What is happening? Something happened to our presentation, but never mind that. Performance is driven by code and infrastructure, period. And there's so much we can do on the infrastructure side, and there's a lot that you can do on the code side. So if revenue is driven by performance and performance is driven by code and infrastructure, always profile your code. No matter how simple it is, no matter how clean and perfect you think it is, I'm sure it's amazing, but profile it anyway. And then work with a hosting partner that really understands performance optimization on Magento, such as Zero Lag. Thank you.